Hello, everyone. Thank you all for being here. My name is Dongxu, the Senior Solution Architect at MongoDB, and I hope you have fun developing with MongoDB. Over years, MongoDB has evolved a lot, especially in recent years. It has become a more powerful and general-purpose database, and it has been used in many critical workloads across different industries. Today, I'd like to take this opportunity to share some of my insight about MongoDB with you, especially since we just released MongoDB version 8, and I hope you all enjoy the session. I just talked about how MongoDB evolved into a full-featured platform, and this chart is I really love, and not just because it gets bigger every year, but also because it tells the story of MongoDB's journey from a database engine to a full developer data platform and a growing ecosystem. And then you can clearly see the investments we have made over the past 10 years from version 3 all the way to the version 8, which we are talking about today. As many of you may already know, we are planning to bring our powerful search capabilities to MongoDB community, including the text search and the vector search. And after that, whether you are running MongoDB on Alibaba Cloud or on-premise, you will soon be able to take advantage of these same search features. And next, I want to take you through 4 key areas that we are going to deeper dive on. The first one is the performance. Not only performance for individual node, but for highly available, highly scalable cluster. And the second is the workload management. We know that in the real world, the production environment don't always behave like the benchmarks. So we're going to tell you about how we handle the variable workload and how we are going to be improving the management of workloads, especially well under the application stress. And I'm also going to take you through some key improvements in how we're making sharding and scaling out more flexible and also more cost effective. And then finally, we will delve into the improvements in security, which are obviously important to your customer. And first is the performance. So let's take a look at what we achieve about performance. One simple way to show the big picture is to look at the industry standard benchmarks. We run this every year to compare the performance across versions, and they have highlights how we have improved read, write scalabilities, and availabilities, as well as the performance on specific workloads. So start off with, we have YCSB, which is the Yahoo Cloud Serving benchmarks. And it is a very popular key value store benchmark. And the second one is the link bench, which is the Meta's social graph benchmark. And thirdly, we have TSBS, the time series benchmark suite, which can help us evaluate analytical workloads and specifically with the time series data. And let's take a look how MongoDB version 8 perform across these benchmarks. When we're talking about the write performance, in version 8, we are improved both our ability to write more data and write back data. And that means if you are using back write or write many, we are seeing about 56% improvement in YCSB backload. And we also improved the YCSB benchmark by 36% or even better for the read 100% test. And we also see a big improvement, about 32% in the test of 95% read and 5% write scenarios. And for the link bench, which, as I said, is focused on a social graph, we have improved performance by 24%. And the last, for the time series, we have dramatic 60% faster. Although real world workloads won't exactly match the benchmark, of course, but this can give a good sense of the kind of gains that you can expect in the common use case with the new version of 8. Additionally, we have made a significant performance optimization to both query execution speed as well as the command execution speed. First, we have optimized the command paths that execute every command in MongoDB to remove inefficiencies but also reduce the amount of memory used. And second, the lower query latency and improve higher request throughput to common workloads and query patterns. We introduced many improvements to common command paths, query plant cache, and it also reduced the number of scans and fetch requires for queries. And MongoDB version 8 leverage a new version of Google tcmalloc memory allocator. And this new memory allocator used per CPU caches, which can reduce memory fragmentation as compared to the per thread cache in use by old tcmalloc. And in testing, we have seen the improved performance while reducing the memory fragmentation size by up to 18%. And the lower fragmentation improved the operational stability, especially during a peak load and unconventional usage patterns. And in order to improve total system performance, we also improve the speed how MongoDB primary, external, and replications interact. Starting in 8, we have optimized MongoDB to handle the concurrent write during replication as well as made the acknowledgement of replication faster. And the result is a remarkable 20% improvement in replication performance, which leads to decreased replication lag and increase the overall throughput for all default like the red concern is majority. Next, let's talk about the workload management. As I mentioned, in the real world, customers don't behave like the benchmarks. The workload can change. So when that happens, you usually have two options: scale the cluster or moderate the workload. But first, you need to understand, is this planned or unplanned? Is it permanent or temporary? And then decide, should you scale further or try to slow things down? To make that call, you need the visibility and the flexibility. That's why we have been improving how MongoDB handles the scaling or the moderation. So here is how we do it to gain visibility and flexibility by workload management. We are using query shape. And the query shape will tell you what database and collection the command executes in, and it will tell you the command to. And it also give you some filter information that we can see here that we have a filter in the account ID. And the important thing you will notice though is at the bottom is the query shape hash. It's more like a unique ID for a query shape. So you can manage your workload in a more smart way with the query shape. Now you can decide whether a query shape should run in your environment. And MongoDB will deliver a new feature, operation rejection filters. With this feature, you can set the threshold and even reject the queries. That allows the customer to block query shapes from the running on specific collection to prevent the expensive queries. And with this, users don't have to wait for the app team to fix the queries, build new index, or wait the node scaling procedures to complete. Instead, once you notice a poorly performing query in the query profiler, the real-time performance panels, or in the query logs, you can now directly to set a rejection filter on the query shape. And once set, the new instance of that incoming query shape will be provided by the database for executing. Once the query has been fixed, the customer can re-enable the query shape. And with the MongoDB version 8, we are giving user more tools to protecting the database from the high-stress workload. And in 8, with the server-side default timeout for read operations, you can protect your queries from these unindexed operations. And you can set a single timeout that impact all read operations coming to the cluster. Any operation that exceeds the timeout will cancel, preventing queries from the running too long and holding on the resources. And if you have some queries which require a different timeout, say analytical queries, you can override them by setting the operation level timeout. And lastly, persistent query settings that allow you to set the index filters for specific query shapes, and they will remain in place even if the cluster is restarted. So next, let's talk about the scalability. As a quick refresher, there are two main ways to scale the MongoDB. The vertical scaling, when you can upgrade to a larger server, larger computer as you need more resources, and horizontal scaling when you need more computers and share the workload between the different shards and different computers. And in the version 8, we have made the sharding architecture simpler and cheaper to set up, and we have made it easier to get started with the distributing data across the shard. One of the current challenge with the shard cluster today is dealing with a single shard that experience high workloads. We call this a hot shard. And the solution to a hot shard is to redistribute the data or reshard the data more evenly across the different shards. But maybe resharding is not the answer because your hot shard involves mainly unshard collections, and all you need to move a collection to a different shard. And this is where this ability come to play. And we are making it faster and easier to move data from an unshard collection to any shard. So now let's see how we can do it in MongoDB 8. And in this case, the order and the product collections are in the same shard. And if we need to move one collection, we say the order collection to a different shard, we say the shard 1. And all this process can be done with a single command, the move collection command. So you can execute a single command to solve a hot shard problem caused by unshard collections. And this new move collection is a major step toward making our system more user-friendly and efficient, to enhancing the scalability without adding complexity. Yeah. So we also have made sharding faster and reliable. And in some case, this means resharding can now be up to 50 times faster than before, and allowing you to adjust the resource quickly and efficiently based on the workload need. And since restart is fully online, it won't disrupt your ongoing operations, and your workload can keep running smoothly without affecting the production. And overall, this makes sharding much simpler and more manageable. And the specific scenario that we test here is splitting a 1 TB collection from one shard to two shard, which involves moving about 500 gigabytes of data. As you can see here, this is the task that sharding would previously have need about 220 hours to complete, almost 9 days, more than 1 week. And with the new resharding in MongoDB version 8, on the other hand, and this takes only 8 hours. That means an operation that used to take days or weeks to complete now only need a half a day. And of course, as we always said, benchmarks are benchmarks and the real world is real world. Your actual performance will really rely on your own workload, your own volume of data, your index, your number of shards. And clearly, this test show that the MongoDB version 8 offer a huge improvement in resharding speed compared to previous versions. And the last area I want to talk about is security. In MongoDB version 7, we release a queryable encryption of equality queries. So now, what is exciting is that we are going to have a support of range queries on encrypted fields, especially number of types of data or data types of data. And this is really going to expand the number of use cases that you can leverage this queryable encrypt for. And this is going to particularly relevant for customer with highly sensitive data requirements, which are usually those in financial service, healthcare, or industry with strict regulatory requirement. And the last feature I introduced in some easing of live logging improvements. In version 8, we are allow you to output your audit logs in this standard OCSF format. And with this option, you can more easily integrate the external monitoring system. And this way, you won't have to do extra development to normalize your log format, which saves you time and effort so you can focus on the building your applications. Yeah, that's all the 4 main areas I want to share about about the new features of MongoDB version 8. And dataset is modern applications grow larger and use case become more complex. Performance is more important than ever. And MongoDB version 8 deliver on those performance expectations by helping application query and transform data faster and more effectively, increasing the throughput and lower the latency. And improved performance can also translate into the reduce your cost, reduce your TCO, and increase the headroom to scale. And simply put, MongoDB 8 has the better performance of any MongoDB version ever. So we say MongoDB version 8 is the fastest MongoDB ever. And at last, we are glad to see that MongoDB version 8 had launched in Alibaba Cloud, and you can try all these new features we just talked about. And there's plenty of resources you can leverage. You can get a 30 days free trial instance. You can have the GitHub code and the YouTube video, and also the free course that you can learn how to develop with MongoDB, and you can contact the sales if you need. And yeah, that's all I want to share with you in this session. And thank you so much for being such an awesome audience. And I hope you enjoyed the session as much as I enjoyed sharing with you guys. And next, we will continue our journey with more exciting topics. I encourage you to stay tuned and get ready for another informative session. And thank you again, everyone. So let's delve into the next adventure.